Group 2 represent about a fight of prey abundant on leaf litter spider bill in Bunlong Nature Reserve of China. Yes, we talk about the predator-prey interaction in the environment that led to the population cycle in nature. Then yes, spider as a predator that they are generally to feed on the insect, arthropod, and including spider also. They are essential in nutrient cycle in the nature, and often it's top-down control. The major of the spider is the consumer in the forest and flow food web. Yeah, functional view of the spider, we focus on the two kinds of the spider, the web builder and the marine spider. The difference of the between web builder and this marine spider. Yes, this web builder create a variety of web and sit and web predator can build within leaf litter, and the marine spider ran widely to find prey. Yes, it can move to find prey. Many hair of fish. Yes, active search predator around his habitat. Our study, we have two predictions. The first, the ratio of web spider to one ring spider will change with prey abundance, because one row will be more successful when prey abundance are higher. And the second of our prediction is the environmental factor and growth predator for species composition in different areas. And Mr. Kim will talk about the methodology.
Our research was in Mongzheng. Spider functional velocity in the later area. We choose seven signs from the Dr. Hysen's course. We choose each day is one. Each day we visited one plot. At each plot we made 4 subplots. Promptly established subplots. We traveled 25 meters to make our own subplots. To make subplot. We measure temperature, lead depth, as cannot cover soil samples and slope. I use 1 by 1 meter quadrant to stop insect and spider from escaping. We use inside the plot we caught spider webs and collected the litter from subplots. We also collected soil samples from subplot. later using the soil sifters. We use hand winkler bags. Winkler bags. We check net 48 hours. We checked net, blank net is for 24 hours. Stored later to release moisture. After finishing, we put for arthropause in the 15 milliliter vials. We then use microscope to identify and classify the arthropause to order. Next, Ms. Tanger.
We use the generalized linear model to test the relationship between different predictors and the responses. This model is suitable for our nested sampling design. Also, we use the CCA to analyze the relationship between environmental factors and the distribution of spider species and samples. In total, we found 25 astropound orders. Among them, Heloptera, immature insects, mice, hamster, and spider are all spiders' prey. Actually, spider eat themselves. No, spider eat other spiders smaller than themselves. Spider is a main prey of themselves. We found about 500 spiders. They belong to 66 species. This figure shows the prey abundance is a good predictor to both web and wandering spiders. They all have a significant positive relationship with the prey abundance. Now, this figure shows the ratio of wandering spiders will decrease when the prey abundance increase. This is not our original expectation, because as mentioned before, we thought when prey abundance increase, the wandering spiders will be more, because the wandering spiders can follow the prey. So this will be discussed later. Then we want to find the relationship between environmental factors and the distribution of species. The CCA analysis show the correlation between the seven environmental factors and the species distribution. And the black circle means different parts, and the red mark means different species. We can see some difference between these. For web spiders, the moisture and the knee coverage play more important role. And for wandering spiders, the soil temperature and breast coverage are more important. The seven environmental factors can only explain 35 and 25% of the variation. So we think maybe there are other important factors.
All right, so how could we have been so wrong in our predictions? We did predict that the ratio would change with increased prey, but we also thought that wanderers would have a higher ratio with higher prey, because again, we thought they could follow prey. Unfortunately, we found the opposite, and we're trying to figure out why. So we looked into some studies, and this guy in 1993 said that possibly some energy investments are made in maintaining the webs, so perhaps they need higher prey densities to do well and have a higher proportion of the group. Another thing that we found, or that we thought about, was maybe that we're doing it at the wrong time. And this guy, Horvath, is really interesting because he found some similar results to us, but not entirely similar. Now, our results showed that environmental factors are somewhat important. However, he said that environmental factors are extremely important, and prey density is a little bit important. And particularly, he said prey density is important for wandering spiders, which, well, it is, but in a negative correlation. So, what our environmental factors show is that moisture and litter depth are the most important. However, moisture is important for web spiders, and litter depth is important for wanderers. And again, we have this negative relationship here as well. Horvath's results showed a positive relationship with litter depth, and in reality, we think this might be because he sampled at nighttime when wanderers are active. We didn't sample at nighttime, so maybe we missed out on some of those wanderers. Also, maybe web spiders have specific selection preferences for where they want to set their webs, because they want to catch the most most prey and spiders. And one species of our web spiders was really successful in taking advantage of high densities of prey, and that was our web spider 7, and I believe it's Therididae. I'm not sure how to say that, but we're interested to see what's going on here, and we're not sure, but we do know that most of them were juveniles, so perhaps they haven't dispersed, but we did find different sizes of the juveniles, so we can say maybe some of them are growing faster, some of them are not growing faster. It's kind of complex to understand. But this guy, Wise, again in 1993, presents a lot of these interesting information in a little book called Spiders and Ecological Webs. Very funny. There are some potential sources of error within our results. We did not account for the predators. If we had more time, we definitely would have taken into account for example, the centipede abundance. We have those results, but again, we need more time to go through the data analysis. We also have Coleoptera, and we have the samples still, but to identify them to functional group would be quite difficult because it's such a diverse order. So to take into account that some coleopterans are prey and some are predators, we really need a lot of time to go through that. And in a 17-day study, we just don't have the time. In conclusion, we have fairly strong support that prey influences our spider gills. Our prediction of how that influence exists was very wrong, but we can also say that environmental factors are a little bit important. And two of those factors that work well in our models are litter depth and moisture. Specifically, litter for wanderers and moisture for web builders. So, thank you very much for your time, and any questions?